Right. Good afternoon. As I said yesterday, today we'll start discussing the past paper questions on Unit 3, Data Representation from 2010 paper. In 2010 paper, part 1, from question number 6 to question number 10, right? So you can refer your past paper book. Question number 6 is 2 GB of memory is equivalent to, right? So the question was arise in 2010 paper, question number 6, right? The 2010 question number 6, part 1, they ask you about 2 GB memory, right? So 2 GB memory, the answer options are 2048 KB, 2 to the power 11 MB, 2 to the power 10 MB, 1024 MB, right? So 2048 KB, 2 to the power 11 MB, and 2 to the power 10 MB, 1024 MB, right? In our class, we discussed that we have to memorize the order first from bit to terabytes, right? So bit byte, kilobyte, megabytes, gigabyte, and terabyte. Right? These are the basic data measurement units you have to consider. And in this case, you must know the relationship between these units. This is 2 to the power 3. Other all are 2 to the power 10. Right? So here the first consideration is gigabyte. So this is what they give. The answers are in megabyte and kilobyte, right? So megabyte 3 answers, kilobyte only 1 answer. So the best way is in megabytes we are having 3 answers. So when we get the megabyte conversion, one of the answer might be the right one. If all are false, without considering this one, you can say this is the answer. Why? Already 3 wrong answers. So this is the answer. So that's the method you have to follow. So first one, you have to convert this one to megabyte, right? So the megabyte conversion. So here you can see gigabyte to megabyte, the relationship is 2 to the power 10. Why? Gigabyte is a larger unit, MB is the smaller unit. So when we consider it in the reverse, we have to multiply. Multiply it by 2 to the power 10. When you have 1 GB, that will be equal to 2 to the power 10 MB. Right? So here 2 to the power 10 MB, that is the wrong option because it is 2 GB. So 2 GB means 2 into 2 to the power 10 MB. Right? 2 units. So here 2 to the power 10. So third option is wrong. 2 to the power 10 will be equal to 1024. That is also wrong. 2 to the power 2 into 2 to the power 10. I can write it as 2 to the power 1 into 2 to the power 10. So when the base values are equal, you can add the powers. So 2 to the power 11 MB. Here we have the answer. So the answer option will be second answer option. Right? So make sure that among the answer options, you have to initially do the highest number of answers in the same unit. Here, answers are in 3 options, megabyte. Right? So that's why I considered that one. Right? So that is the 2010 question number, part 1, question number 6. Now I consider 2010 question number 7. Right? So question number 7. It's a number system conversion. So question number 7, the octal equivalent of binary number 11001. Right? So 11001 is the given binary. They ask the octal equivalent. So binary to octal conversion. Right? When you're doing a binary to octal conversion, you have to write the binary number. Then divide it into 3 digits groups from right to left. The reason behind it, this is 2 to the power 3. Right? You can memorize that one. So the octal equivalent, you have to multiply it by 2 to the powers. So 1, 2, 0, 1. So here 2 to the power 0 is 1, 1 into 1, 1, others are 0, so leave it. 2 to the power 0 is 1, 1 into 1, 1. 2 to the power 1 is 2, 2 into 1, 2. So 2 plus 1, 3, 1. So 3, 1, base 8. That is your answer. In the question number 7, the answer option will be second answer option. Right? So second answer option is your answer for the 2010 paper, question number 7 in the part 1. Right? Write down the methods also. Right? So that's the end of 2010 paper, question number 1, question number 7. Now part 1, question number 8, I will consider. Question number 8. Which of the following is the largest one? Right? So they ask you the largest one among the binary values. Right? So I will explain it very quickly. Here, the first answer option is 1001100 base 2. Second answer option is 1101010 base 2. And the third answer option is 1010101 base 2. Fourth answer option is 11 5 times 0 base 2. Right? So they ask you the largest one. Right? There's a very simple method to do it. Right? You have to know that the method is from left to right, you have to consider and compare each digits. Here you can see there are 7 bits. Here also 7 bits. Here 7 bits, here also 7 bits. So number of bits are equal. When you are having number of bits are equal, you can follow the method from looking the bits from left to right. Right? So from left to right, you have to consider. Right? You have to know that when this value, when you consider this digit value, this value will be always greater than the entire digit's total value. Right? So this digit will have the greater value than the entire right side units. Right? You can do it manually and determine whether it is true or false. Right? So here, largest unit they ask. So from left to right, I will consider first digit 1, 1, 1, 1. So no elimination. Second digit 0, 0, 0. But here it is 1. As I said earlier, when you are having a 1 here, the balance bits, whatever the value, 1 no 0, whatever it is, will be less than this digit. So straight away, we can get the answer as this one. Right? So largest value, you have to look at the bits from left to right. If first bit is same, compare the second bit. If second bit is same, compare the third bit. Likewise, you can do it. Right? So the answer option will be fourth answer option. So that's the end of question number 8. Now I will consider question number 9. If the character C is represented as, it's a ASCII question, right? ASCII conversion we have to consider. So question number 9. So question number 9 in 2010 paper, consider the question. If the character C is represented as 1000011 base 2. So C 1000011 base 2. What is the equivalent ASCII code for character A? Right? So they ask character A. You have to memorize that. You can remember in ASCII, capital letters are having the lesser value than the small letters. From A to Z, there will be one value increment. After some time, then we will start from small a to small z. Here also, the relationship will be increased by 1. Right? So that is the relationship. So when they are asking C, capital C is between the A and Z. Right? So now they ask you to consider the letter A. So capital A must be before C. Why? From A to Z, there will be a value increasing by 1. Right? So C, here A. So between C and A, we will have B. So they ask the ASCII value for A, 1, 2. So you have to subtract 2 values to find out value of A. So 2 in binary, 1 0 0 1. So 1 0 base 2 is your binary value to be reduced. to find out the A. So write 1 0 0 0 0 1 1 2 minus 1 0 base 2. Right? So we have to perform the subtraction process. Right? Binary addition, binary subtraction. We already learned in grade 9. Like not only in ICT, also in mathematics. Right? Mathematics, you had the addition and subtraction of binary values. So here, binary subtraction 1 minus 0, 1, 1 minus 1, it is 0, 0, 0, 0, 0, 1 base 2. Right? So when you consider the answer options, that is the first answer option. That's the end of 2010 part 1, question number 9. Right? Now we will consider 2010 part 1, question number 10. Right? So question number 10. A teacher enters the number of students in the class as 35 into the computer using keyboard. Right? This number is represented in the random access memory of the computer in binary form. The number of students stored in RAM is, right? It's an unwanted paragraph or phrase they gave. The simplest way of representing this question is, or conveying this question is, you have to find out the binary equivalent of the decimal number 35. That is your question. Very simple question, right? So you're going to convert the decimal number 35 into binary number, right? So 35 decimal to binary conversion I'm going to perform. 35 will be divided by 2, 17 1, 8 1, 4 0, 2 0, 1 0, 0 1. So your answer will be 1 0 0 1 1 base 2. 1 0 0 1 1 base 2. Fourth answer option. Right? So that's the end of 2010 part 1 questions. Question number 6 to question number 10. Right? In 2010 part 2, right? As I said earlier, in grade 10 units, unit 1, 2, 3, 4, 5, all these questions will be as your compulsory question in your O-level paper, right? Sometimes M.C.Q questions and part 2 compulsory question. The first question it will have 20 marks. So in 2010 paper, there are 2 questions, right? So 2010 part 2 questions I will consider. So in 2010 part 2, question number 1, Roman number 5, with part 5 and 6, right? Part 2, question number 1, part 5. The question is, convert the binary number 11001110 11001110 into hexadecimal equivalent, right? So this is binary to hexadecimal conversion. Binary which is base to hexadecimal which is base 16, right? So here you have to do the conversion, rewrite the given value with little bit space provided. This is 16, so 2 to the power 4. When you convert the binary number into hexadecimal number, you have to do the grouping from right to left as 4 digits group, right? This is 2 to the power 4, which is 16. Then you have to multiply it by 2 to the powers. 2 to the power 1, 2 to the power 2, 2 to the power 3. This is 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3. Right? We can remove this one. 2 to the power is 1 is 2, 2 into 1, 2 plus 2 to the power 2, it is 4, 4 into 1, 4, 2 to the power 3 is 8, 8 into 1, 8. This is part 2 question. So it is compulsory to write these things. The steps also will have the marks, right? So make sure to write these steps. Now I will consider next part. I can remove this one because multiplied by 0 will be 0. 2 to the power 2 is 4, 4 into 1, 4, plus 2 to the power 3 is 8, 8 into 1, 8. So 8 plus 4, 12, 8 plus 4, 12 plus 2, 14. Here you have to remember that this is one single number, right? So 14 in hexadecimal will be denoted by E. 12 in hexadecimal will be denoted by C. Why? 10 is A, 11 B, 12 C, right? So the answer will be C, E, base 16, right? So this is 2 mark question. For these steps, there will be 1 mark, and the final answer will have the 1 mark. So altogether 2 marks. So in 2010 paper, you can realize the importance of unit 3, right? In unit 3, we have a question number 6, 7, 8, 9, 10. 5 M.C.Q questions, 5 marks. Now it is 2 marks, right? Not yet over, right? Question number part 6 also the same unit question. Now I will consider part 6, 2010, part 2, question number 1, part 6. Convert the number of bytes in 1 KB into the octal equivalent, right? I'll tell the question again. I'll read it again. Convert the number of bytes in 1 KB into the octal equivalent, right? So here one KB is given, you have to get the number of bytes and then convert the number of bytes into octal equivalence. That is what they ask, right? So here, first you have to convert 1 KB into bytes, right? So bit byte conversion, bit byte kilobyte. So from kilobyte to byte, you have to multiply it by 2 to the power 10. So 1 KB you have to write. This is your answer, right? So you have to start from here. 1 KB equal 1024 bytes. Now we have to convert 1024 into octal format. When you divide by 8, it will be 1280. When you divide by 8, it will be 160. Right? When you divide by 8, 20. When you divide by 802, the answer will be 2000 base 8. So this one will have the marks, this one will have the marks, this one will have the marks. All together 2 marks. So in 2010 paper, this is 2 marks. So you can see 9 marks questions came in 2010 paper, but all these questions are compulsory questions. That's why I am telling again and again, be very, very clear about the unit 1, 2, 3, 4 and 5. Like you can't ignore it because all are compulsory questions. Right? So that's the end of 2010 paper. Now we will consider 2011 paper. If you want, you can write this. Right. Now we will consider 2011 paper. In 2011, question number 5 to 10. Right. So from 2011 paper, there are 6 questions in part 1. So 2011, 6 M.C.Qs. 2011 part 1, question number 5. Right. The question is, what is the equivalent of value for decimal value 125? Right. So they ask the equivalent decimal value of 125. Before you proceed, you can see there are two binary answers, one octal answer, one hexadecimal answer. Right? So two binary answers. First one is a binary answer, second one is a binary answer, third one is octal, fourth one is hexadecimal. But usually, most of the times, right, the answer will be in the majority answer type. Here there are two binary values given. If you perform the binary conversion, sometimes you can get the answer. Otherwise, you can eliminate two answer options. Right? The two answer options you can eliminate. So I will convert the 125 decimal number into binary. Right? 125 will be divided by 2. You can get 62 1, 31 0, 15 1, 7 1, 3 1, 1 1, 0 1. But so your answer will be 1 1 triple 1 0 1 base 2. When you consider answer option 1 and 2, there are 8-digit answers. So to make 7-digit answer into 8-digit answer, you can put 0 in front of the binary value, right? So that is done. So you can compare the first answer in your answer 0 1 0. So that is wrong. Second answer option is 0 5 times 1 0 1. Here 0 5 times 1 0 1. So your answer option is second answer option. So always go through with the majority answer types, right? Most of the times you can get the answer. So that's the end of 2011 paper, part 1, question number 5, right? Now we will start discussing 2011 paper, part 1, question number 6. Right? Question number 6. What is the value does the symbol C represent in a hexadecimal number system? Right? So C in hexadecimal number system. Hexadecimal number system, A will be equal to 10 and F will be equal to 50. So C will be 12. 12 means it is base 10. So 12 base 10 will be a straightforward answer. But when you consider that one, your fourth answer option is 13 base 10. So we have the fourth answer option 13 base 10. And the first answer option is 1011 base 2. And the second answer option is 1101 base 2. And the third answer option is 14 base 8. So C is having the value of 12 in decimal. That's why fourth answer option is eliminated. We are having 1, 2, 3. Here in balance these 3, we have majority of binary value. So I will convert 12 into Byte. So 12 divided by 2, 6, 0, 3, 0, 1, 1, 0, 1. So your answer will be 1100 base 2. 1100, no. 1100, no. So done. So I have done only one step, but you are having 4 answer options. So that is the most important way of approaching the paper in a proper manner, right? That is the end of question number 6 of 2011 paper part 1. Now we will consider the next question. 2011 part 1 question number 7. Right? Question number 7. Two computers, A and B, are having memory capacities 1 GB and 1024 MB. So A is having 1 GB, B is having 1024 MB. Right? So 1 GB, 1024 MB. When you are having the relationship between the units bit byte, kilobyte, megabyte, gigabyte. So gigabyte to megabyte, you have to multiply it by 2 to the power 10. 2 to the power 10, which is equal to 1024. So 1 GB and 1024 MB are equal. But so here, statement 1. So what is the correct statement regarding their memory capacities? Computer A has the highest memory capacity than computer B. That is wrong. So first answer option is wrong. Second answer option, computer B has a highest memory capacity than the computer A. That is also wrong. Why? Both are equal. Both have equal memory capacities. That is the right answer option. Fourth answer option, memory capacities of the two computers cannot be compared as a different units of measurement are used. When you are having different units of measurement units, you can convert that measurement units into same unit and compare. So there's no worries. So the correct answer option is third answer option. Both having equal memory capacities. Right? That's the end of 2011 paper, part 1, question number 7. Now we will consider 2011 part 1, question number 8. Right? So 2011 part 1, question number 8, I will consider now. Salmon has an electronic presentation of size 10,256 bits. 10,256 bits is the capacity of the file, right? What is the minimum capacity of the portable flash drive that can be used for storing this file? Right? So they are asking you to find out the minimum capacity needed to store this file in flash memory. They didn't ask about the maximum. Why? Maximum cannot be determined, right? They are asking minimum capacity, right? Minimum capacity. When they are asking you the minimum capacity, what you have to do is first consider the units, measurement units they provide. Here the first answer option is 256 bytes. 256 bytes. That is your first answer option. Second answer option 1 KB, 1 MB, 1 GB. So this is 1 KB, 1 MB, 1 GB. Right? They ask you the minimum capacity. So bits to byte conversion. So as I said earlier, bit, byte, kilobyte, megabyte, gigabyte. Right? So what I am going to do is I am going to convert 1256 bit to bytes. So from smaller unit to larger unit, you have to perform the subtraction. So the relationship between the bit and byte is 2 to the power 3. When you go back to bytes to bits, you have to multiply it by 2 to the power 3. When you are coming from bit to byte, you have to divide it by 2 to the power 3. So what I have to do is I have to divide 10,256 by 8. Right? So 10,000, when you consider it as 10,000, nearly, when you divide it by 8, it will be more than 1,000. Right? 10,256. When you divide it by 8, it must be greater than 1,000. Why? Within 10,000, 8,000 is enough, right? So, minimum more than 1,000 odd bytes will be your answer needed, right? So, 256 bytes is not enough, right? So, 10,256 divided by 8 will be equal to greater than 1,000. That's why I removed this one, right? We will consider the kilobytes. So you have to divide it by 2 to the power 3, again divide it by 2 to the power 10. Right? So 10,256 is going to be divided by 2 to the power 13. Right? 10,256. Right? In number system questions, you have to know about one important fact. They never give you the most complicated questions like division or multiplication. They never provide you the complicated ones, right? So simple as that one. When I divide it by 8 to get the bytes values, it will be 1,024. You can see this one. 10, 22, it will be 2. So here 16. Yeah, 16 and then 6, 5, 8, 64, 1, 6, it is 2. 1,282 bytes. Right? So this is not enough. So when you convert byte to kilobytes, you have to divide it by 2 to the power 10. So 2 to the power 10 means 1024. Right? So your answer is now in bytes 1282, but we need the kilobyte conversion. When you have the kilobyte conversion, you have to divide it by 1024. So 1282 will be divided by 1024. You will have one time 1024 8 5 2 0. So 2258. When you add a 0, you have to make 5. So more than 1 KB is needed. Why? Byte to kilobyte conversion, you have to divide it by 2 to the power 10. So 2 to the power 10 means it is 1024. When I divide 1282 by 1024, that is 1 point odd. So greater than 1 KB. So that is not enough. So it is 1 point odd. The answer is 1 point something KB. When you consider 1 MB, there will be 1024 KB. But I need 1 point odd KB. Right? So 1 point odd KB. Here I have 1 MB. So 1 MB is more than enough. 1 GB also we can use, but they ask minimum capacity. That's why third answer option. Right? That is your question number 8 of 2011 paper. Now I will consider question number 9 of 2011 paper. Question number 9, binary coded decimal uses 4 bits to represent each digit in the decimal number system. Which of the following is a valid bit pattern in BCD? Like this same type of question I gave you in the class for your practice. Like I can remember that question. I gave you 6 or 7 BCD patterns and asked you to determine whether they are valid or invalid. So 2011 question number 9 of part 1. They gave 4 BCD patterns and asked what is the valid one. 0 0 1 1 1 0 1 1 1 1 0 0 1 1 0 1. Right? So you have to get an idea about BCD. So BCD conversion is done. The decimal number will be divided into single digits. Each and every single digit will be separated. And that separated numbers will be converted into 4-digit binary value. So when I consider a decimal number, the minimum value will be 9, maximum value will be, minimum value will be 0, maximum value will be 9. So when you convert these numbers into decimal, if you are getting the values from 0 to 9, those are valid. If you are getting more than 9, that is invalid. Here, place value is 1, place value is 2. So 3, it is valid. Here 1, 2, 4, 8. 8 plus 2, 10 plus 1, 11. 11 is not possible. If you want to represent 11, you have to make it as 1, 1. Here, 8, 4, which is 12. 8, 4, 1, which is 13. So here in BCD, you have to remember the decimal value of this given binary pattern must be from 0 to 9. Right? Because we will get a decimal value and then divide it into single digit group. Then each and every digits will be converted into 4 digits binary format. Right? The 4 will be 1, 0, 0 and 1 will be 0, 0, 0, 1. That's why the answer option is first answer option, right, in BCD format. That's the end of 2011 paper, part 1, question number 9. Question number 10, it is again ASCII. The ASCII relationship, which I already explained in 2010 paper. So I am not going to consider the ASCII pattern. Straight away I will do the question. Right? 2011 question number 10. That is came from ASCII conversion again. In 2010 also we had that one. 2011 also it came. Right? When you consider the question, if 1 5 zeros 1 1 5 zeros 1 represents A in ASCII. This is A. Which of the following is represented by 1 0 0 0 1 1 0 0 1 1? Right? As I said earlier, when you consider the digits from left to right, 1 1 0 0 0 0 0 0, this is 0, this is 1. So this means this is the largest value. Right? So I will subtract the unknown one minus A. Right? Then we can get the difference. Right? So 1 0 0 0 1. I will perform the subtraction of this one. 1 minus 1 0 1 1 0 0 0 0 0. The answer will be 1 1 0 base 2. 1 1 0 base 2 in decimal 2 to the power 1 2 to the power 2. 2 plus 4, that is 6. Why? 2 to the power 0 is 1, 2 to the power 1 is 2, 2 to the power 2 is 4, 4 into 1, 4. So 4 plus 2 plus 0, which is 6. So this one and this one, this unknown character or letter will have 6 values greater than the A. Right? So I will write the alphabets A, B, C, D, E, F, G. 1, 2, 3, 4, 5, 6. It is capital G. Right? This is how you can determine the answer. So the answer option is fourth answer option. So in 2011 paper, there are 6 M.C.Q questions you have to consider. So, but I will write the marks as 6 marks. in 2011. This is part 1. Now we will consider part 2. Right? So in part 2, compulsory questions came. In part 2, question number 1. Right? In 2011, part 2, question number 1, there were 2 questions, question number 5 and part 5 and part 6. Let's read the part 5. Correcting encoding schemes are used to represent symbols within computers. The number of symbols represented in a computer depends on the number of bits used. I already mentioned that one. We already performed the number of color calculation process, right? When you are having 2 bits, there will be 4 colors. Likewise, we do the conversions, right? How many different symbols could be represented using 8 bits? Show your computation, right? So you are having 8 bits. So you are first you have to write it is 8 bits, right? So number of characters can be represented by using 8 bits will be, right? You have to write like this: 2 to the power 8, which is 256 characters, right? This is your answer for the 2011 part 2, question number 1, part 5. Right? Question number 1, part 5 question, 8 bits. So part 5 we will have 2 marks here. Now we will consider part 6. Part 6 also came in 2011 paper, based on convert the hexadecimal number C9 into binary, show your computation, right? So hexadecimal number C9 is given. They ask you to convert it to binary, and you have to write the computation steps, right? Always in part 2, write the computation steps. It is must. Not only must, you will have marks, right? So computation steps you have to write. Now I will consider the question. C9 is going to be converted into binary numbers, right? So you have to write C9 base 16, C9, C will be 12 and 9. When you are converting the hexadecimal number into binary number, you have to write the each digits in 4-bit binary format. When you divide the number 9 by 2, it is 41. Again 2, it is 20. Again 2, it is 10. Again 2, it is 0, 1. So the answer will be 1001. 12, when you convert 12 divided by 2, it is 60, 30, 11, 0, 1. So the answer will be 1, 1, 0, 0. So when you convert C into binary format, first you have to determine the decimal value, which is 12, then convert it into binary 1, 1, 0, 0. 9, that is 1, 0, 0, 1. Right? So you have to combine the two values. That will be your binary equivalent. 1, 1, 0, 0, 1, 0, 0, 1 will be your answer. So here we will have 1 mark for this one and 1 mark for this one. So here Roman number 6 also we have, that is 2 marks. Altogether 10 marks, which means 10%. Why? All are compulsory questions. So 10% of your final exam paper will have the number system or data representation, right? In 2010 and 2011, right? So today we discussed about 2010 past paper questions, part 1 5 questions, part 2 2 parts, 2011 6 MCQs and 2 parts, right? So that's it for today. We already discussed 2 papers, 2010 and 11. In the next class, we will discuss 2012 and 2013. Right?